Good morning, everybody. It's a pleasure to speak to you today about this exciting new business area. So I'm just going to jump right in. The U.S. Navy has two major challenges in front of it, rust and China. Rust is still the undefeated heavyweight champion of the high sea. As you can see here, the USS Fort McHenry pulling in for decommissioning with all that running rust. Unfortunately, that's fairly common in today's U.S. Navy. The second being China, which has just quietly developed 232 times the shipbuilding capacity as compared to the United States. So it's currently estimated that it costs about 1/6 the cost to build a ship in China versus the US. So what does the US shipbuilding market look like? It really hasn't been modernized since World War II, and unfortunately it kind of shows. There's significant challenges with the US shipbuilding community right now. The first is a lack of US suppliers. There's really only a defense sector in shipbuilding. There's not a lot of commercial shipbuilding in the United States. Second, the trades workers, they are retiring. The best shipbuilders in the world are retiring, and there's not a lot of young people to take their place. Finally, there's not very many advanced manufacturing techniques being utilized by the US Navy. You can see this image here with flames shooting up. That's actually a forging process. This is still how they manufacture lots of parts of the ships. I actually put my eyes on one of these in Newport News, Virginia. And they use sand castings and they use a wooden template. And that wooden template, they said, I sure hope that never catches on fire because that's the only one we've got. So finally, I'll call your attention to the USS John F. Kennedy. This is the most advanced warfighting ship in the world. This is a ship built in 2019 is what you see in this image right here. And just take a special mental note of all that rust on the exterior. I'll expand a little bit more on why that is later. The bottom line is shipbuilding is dirty, dull, and dangerous work, and we feel it's ripe for automation. So at SwRI, we have a long legacy of building custom robots. I'm trying to take them to deep sea, and my colleague Mira Towler will actually talk deep space robotics research a little bit later this morning. But these robots that you see here are actually depaint robots. They're for taking the paint off of aerospace structures. So they either use a sandblasting process or a laser ablation process. So very custom robots that we've built. In addition, we've built some other unique robots. So this angled rail robot here is a Swiss Army knife robot that comes in and is able to do a sanding process, an inspection process, really whatever the client needs. And finally, we've done custom paint robots as well, which is just a fairly mature technology in robotics, but it's worth mentioning that we've dabbled in that market as well. So we hypothesized that two technologies would be most interesting for the US Navy. First, ships are very large, so we're going to need a mobile robot to come to the side of that ship. But what does the robot do when it gets there? That's where our second technology comes in, which is called scan and plan, where the robot can come down and take a look at what is in front of it. It uses a 3D scanner, and then it can detect areas that it needs to further process. In this case, we're actually throwing sparks here because it detected there's two risers of this steel casting that needed further processing. So it comes down and automatically blends it, no programming required. So we show this latest and greatest technology to the Navy, and they agree that it's really, really cool, but unfortunately, they ask us to sweep the floor. So what's going on in this image is before you can paint a ship, you actually have to take all the rust off of the steel. And so you use a steel grit blasting process to prep that surface, and you return that steel to white metal. Unfortunately, all of that grit and debris falls on the ground, and today, trades workers go in and recover that with shovels, buckets, and wheelbarrows if they're lucky. So our shipbuilding partner has estimated that it's about 5 million pounds a year is recovered, all with backs. So that's not great. So SwRI has been awarded what we've affectionately called the Blast Roomba project, where we're going to drive through this area. We are currently in the build state, so we're starting to procure components now. We've built a Zamboni, more or less. It's going to drive back and forth through this region. It's going to vacuum up all of that grit. It's going to store it on an onboard hopper, and whenever that hopper gets full, because the steel grit's very heavy, it fills up pretty quickly, it's going to go and dump that in the reclaim area. So the Navy is thrilled that those people don't have to walk around with shovels and wheelbarrows any longer. Up next is a painting project. We've been awarded another painting project. So in this case, ships start out as flat steel plates. And they get a little bit more complicated from there. They add struts and structure and combings, and they cut holes in it. But as I mentioned, they don't have enough people. So right now, they just let that rust. So call back to that image of the brand new aircraft carrier. It's a production bottleneck for them. They don't have time to paint these panels. So what do they do about that? Asked us if we can apply our scan and plan technology to that problem. So what we can do now is we can present a brand new panel to our robot and say, hey, take a look at this. What would you do to paint it? And it can automatically generate those painting files to paint that. So clearly that's a sped up video, but what we can do is about a 60-foot long panel that's 20 foot tall. We can do that in about an hour. And so that's a game changer for the Navy. It really helps us close that production capacity with China. So lastly, I'm going to talk to you about the next big opportunity in robotics for shipbuilding. And so ships on the interior, they're very dangerous confined spaces. So you can see this image here on the lower left that it's really a ballast tank with a labyrinth of baffle plates. And all of this work that I've been talking about, trades workers have to crawl through that maze and do this very confined space work. And so it's actually very dangerous for all these workers to be in there. Shipyards have put in lots of dangerous, laws and as well as permits to make sure that they can't hurt themselves. And even so, skimming the OSHA website, we found 4 recent fatalities in this market. So what is Southwest Research doing about this issue? So you might have seen in earlier talks that we've actually developed some concepts of how to start to negotiate these areas with custom robots. And so now we've invested in a internal research program here to actually develop this hardware. And to make sure that our shipbuilder partners know that we're serious, we actually went down to Brownsville and we found a part of a decommissioned ship. And so the U.S. naval ship Second Lieutenant John Bobo may rest in peace, or at least a piece may rest in my lab so that I can crawl through it. So right now what we're doing is we're developing this internal research at baseline functionality. So first we're going to try to do the locomotion. And this is a field of dreams sort of research area that we know once we demonstrate that we can crawl through these regions, the clients will come with all sorts of different applications, whether it's painting, welding, blasting, or taking them into even more dangerous areas such as the nuclear reactor core. So all the while, what makes this research cool is we get to focus our attention on that North Star, that this will be foundational research to eliminate all deaths in confined spaces.
Well, the demand and its supply gap, especially relative to China, is current motivation for investment. In addition to the U.S. Navy, South Korea is currently heavily investing in the U.S. shipbuilding capabilities. South Korea happens to be second behind China at about 30% of the commercial shipbuilding market, enabled primarily by the use of modern techniques and advanced technologies that we don't currently use. If we learn from Korea, we get their know-how, we get their help, the question still remains as to whether or not we can catch up to China. Now, meanwhile, in Philadelphia, the Philly shipyard is now owned by a Korean company, and they're already too busy. This is as of just 2 years ago. So this implies that there's lots to do in this particular area. And at the same time, robotics for shipbuilding is a growing trend and a promising trend, and a good market as well, with a market value estimated to exceed $6 billion by the year 2030. Now, SwRI is building a strong foundation to contribute in this area. With South Korea as a U.S. shipbuilding ally now, SwRI has been engaging with them and is now winning contracts. We have been building on internal research results, basically in robotics as well as machine learning, and I've come up with an approach to using multiple mobile welding robots with embedded welding intelligence to actually work along with skilled mobile welders at these shipyard sites, all working on the same part. The SwRI solution will also provide a means for orchestrated tasking of the activities of these various pieces. So we're contributing in that way, and this is just the tip of the iceberg. Now, in this business area, Cody will tell you, we aim to take robots where they've never been, doing things they've never done. And if we're successful, SwRI will be able to contribute to increasing safety by reducing injuries, as well as creating a safe environment for robots and humans to work together collectively in these shipyards. We'll also impact operations as well in terms of lower cost of our labor, greater efficiencies in ship production, as well as more precise, more consistent build quality in our ship development. And finally, we'll develop innovative robotic solutions that help to advance modern shipyard automation and helping to close the gap with China. Ultimately, with SwRI becoming the go-to solution provider for maritime and naval robotics. So thank you for your attention. Cody and I are glad to take any questions you may have.
Okay, we're ready for your questions right back here. So is China's shipbuilding industry automated or a result of just a large number of people they can put on their projects, is the question.
Yeah, I would say both, but it's definitely the latter. They are way ahead in terms of the technologies that they use and the techniques that they use. Their shipyards are highly automated. They've already been using robotics and other advanced technologies, AI included, and so they are very well adept at applying the technologies, but certainly there's lots of staff to help as well.
Right up here.
Yeah, so are the things that you're planning to do leapfrogging what the Chinese are doing or capable of doing?
So the question is, are you leapfrogging off of what the Chinese is planning to do?
I wouldn't say leapfrogging quite yet. The main thing right now is trying to find ways to catch up. And we hope to learn from the South Koreans because they also are taking advantage of the technologies and the modern techniques that they're bringing via the Philly shipyard. And we hope to learn there and start to accelerate our advance.
I would add one other, is the confined space crawling work, that would definitely leapfrog. There's nothing else that can solve that issue.
Do we have any other questions? Okay, thank you, Eddie and Cody.
Thank you.
Thanks.